We were talking earlier about trigonometry and about angles in standard form, meaning that we had an angle that would start on our positive x-axis and would rotate counterclockwise, and then that would be our initial side, and then we would have a terminal side. Something like there's our initial side, and here's our terminal side. And then we had some sort of angle rotation. We're going to use some of that similar information to start with plotting polar coordinates, which will lead us into our vectors. So typically, we have plotted on an x and y plane. Now we're going to use a polar plane. And with a polar plane, a coordinate reads r and theta. The r stands for the radius, and the theta is the rotation. Now, the one thing that you have to understand is that the radius is a little bit different. Before we were making triangles, and our radius was the length of that hypotenuse. Well, when we're on a polar plane, our radius is actually what we originally know as our radius is from a circle. So the distance from the center of the circle to the actual arc of the circle. So if you look on the polar plane, we have a circle here. That would be radius of 1 unit. We have a circle here. That would be a radius of 2 units. 3 units, and so on. So what we're doing is we're only going to plot one point rather than an entire line. How we do that is we have some steps to follow. The easiest way to do that is actually to do our rotation first and then count our radius lines. Or I guess I shouldn't say lines, I should say circles. Now, on this graph, you can see we have 1, 2, 3, 4, 5 lines that equally divide between 0 and 90. So that means that each one is 15 degrees. And all polar planes are slightly different. 60, 75, and 90. Let's actually try and do a problem. So plot each point. Remember I said step 1 you want to do the rotation. Now each of these are 15, so that means that my rotation is going to take me to the second line. So that's my terminal side. And then my r value is a 2. So therefore, I go to my center and I count out 2 circles. 1, 2. That coordinate is radius 2 with a rotation of 30 degrees. Now, I'm going to come back to this. So for the next one, I'm going to rotate negative 240. So the negative means that I'm going to be rotating in the clockwise. There we have negative 180. I'm going to need to go another 60 degrees, which brings me to this line here. So here is the actual line of my terminal side. Now, I'm not supposed to be graphing the line, I'm just trying to show you. Then I have a negative 3. Now, this is where you have to be very aware. We can never have a radius that's equal to a negative number. So really, this negative is actually talking about a direction. So rather than count 3 circles along that terminal side, we're going to count 3 circles along the alternate side. And when I say alternate side, imagine that we reflected this terminal side. If we reflected it, it'd be down here. So that means that the 2 sides have to be an equivalent straight line, meaning 180 degrees. Now I'm going to count out the 3 circles are on the negative direction. 1, 2, 3. That is my point. Now let me just erase the part that's not actually part of the answer. Alright, I'm going to go back to the first one now. So I told you that this coordinate of R2 and 30 degrees creates this point. Well, because we can rotate clockwise and counterclockwise, as I showed you in both examples, and now we can have a radius in a positive direction and a negative direction, we can actually give 3 other coordinates that will land us in the exact same spot. Now I want you to listen very carefully to this. Whoops, I just erased that. So when we're trying to find the other coordinates, we're trying to find the coordinates that will leave us in the exact same position. Well, one of them, as I just showed you, we can use a negative radius. In order to use a negative radius and end up in this exact same spot, that means that I need to rotate to its alternate angle. So instead of just rotating to 30 degrees, I'm going to rotate that 30 degrees plus 180 degrees. And now I am looking just at this side. But wait a second, my actual coordinate is not there. My coordinate is in the opposite direction. So that means I need a negative, which will count me back into quadrant 1. 1, 2. Negative 2. So I simplify that. It gives me negative 2 to 10 degrees. Now I just gave you 2 different answers with positive angles that end up in the exact same spot. Well, now I can go in my negative direction. So I'm going to rotate all the way around to here. What sort of rotation is that? Well, first of all, it's in the negative direction. I'm going all the way to here. Remember, this is 30 degrees. So it looks like I'm rotating negative 330 degrees. And if I'm rotating onto this terminal side, well, the point is on that terminal side, so that means my radius is going to be positive. For my last one, I'm going to need a negative radius. Well, in order to have a negative radius, that means that I'm going to only rotate to this red line. So initial to the red line. So how much am I rotating? Well, I'm not rotating quite negative 180 degrees. I'm only rotating negative 150. So I rotate to this red line as my terminal side. The point is not there. So I put a negative and I count 2 in the opposite direction. Here are the 3 additional points that will get us to the original radius 2 and 30 degrees. Now let's look at the next one. We have a negative radius and a negative rotation. So we need another negative rotation. But we need it to have a positive radius. Well, our radius is going to be 1, 2, and 3. And in order to get there with a negative rotation, I'm rotating in the negative direction to the actual line. And that looks like it is negative 60. My next one is a positive rotation with a positive radius. So I've got to rotate all the way to the line. So what is that rotation? Well, this is from here to here, 60 degrees. So therefore, I'm rotating 300 degrees, and I have that positive radius. Now I need to rotate in the positive direction, but I'm going to have a negative radius. So that means that I need to have my terminal side be the alternate angle, because I have that negative radius. So I have a -3, so that means I actually need to stop on this terminal side and then count in the opposite direction. So we have that 60 degrees here, so 180 minus 60 is going to be 120 degrees. And then we already have that last one. Now we need to be able to move back and forth between polar coordinates, which is r and theta, and rectangular coordinates, which is x and y, because really we just have our polar coordinate and our rectangular coordinates overlapping with each other. So the equation to get x is r cosine theta. The equation to get y is r sine theta. Hopefully they look a little bit familiar to you. If you were to divide both sides by r, let's say in the second one, we get sine theta is equal to y over r, which we used from our SOHCAHTOA. So that's where the equations are pulled from. Now, if we're going to go from xy to r theta, it's a little bit different. The relationship between the xy and the r is actually the equation of a circle. So r squared is equal to x squared plus y squared. And then you can take the square root. And so that's your r. To find your angle, because you're only given an x and a y, you have to use tangent, which shows a relationship between x and y. So what you would do is you put your relationship together, taking the coordinates, and then take the inverse of tan. Now the calculator will only give you an answer between -90 and 90. So unfortunately it will only give you an answer in quadrant 4 and quadrant 1. So that means that if the x value in the question is negative, then once you get your theta, you need to add 180 degrees. And I will show you in a problem. The first one, we're given r and theta, so that means we're going to go towards x and y. So we're going to use our equation, x is equal to r cosine theta. We'll sub in what we know, -2 cosine of 150 degrees, and then you're really just going to go to your calculator. Make sure your mode is in degrees because you're entering degrees. -2 cosine of 150 is 1.73. To find the y value, -2 sine of 150 is equal to -1. So the coordinate is 1.73, -1. We do the same thing for the second one. This is your r and theta. We're going to go to x and y. X is equal to r cosine theta, 3 cosine of 250. That's going to give us -1.02. And then our y value, 3 cosine of 250, will give us -2.81. So our coordinate is -1.02, -2.81. Now let's go, just so you know, that's a -x and a -y, so that should be in quadrant 3. And this is a positive x and a -y, so this would land in quadrant 4. So basically what I'm saying is that if you were to overlay -2, 150 degrees as our polar coordinate and lay it over top of an xy Cartesian plane, that exact point will line up in the spot of 1.73 and -1 for our x and y. Last, we're going to go from the polar coordinates to the, find the polar coordinates. So we have 2, -4, 2, -4. We want r and theta. So to find r, that's the square root of 2 squared plus -4 squared, which is square root of 20, which we'd simplify to be 2√5. And our theta, so tan theta, is going to be y over x, -4/2. We take the inverse tan of -4/2, and we put that in our calculator. When we do that, when we put it in our calculator, we get -63.4. So -63.4 means that we're rotating clockwise. -63.4. And that's degrees. For the next one, we have -8, -12. -8, -12. To find r, that's that square root of x squared plus y squared. Notice that we are in quadrant 3. We have -8 squared plus -12 squared, which is root 208, which is the same as 16 times 13, so 4√13. It's our radius. 4√13. Okay. Then to find the angle, we have y over x, which is -12 over -8, tan -1. Now, because this is in the third quadrant, we're going to have to add 180 degrees to it. Because when you go and put it into your calculator, you get 56 degrees. Well, 56 degrees is in quadrant 1. You can clearly see that my point is not in quadrant 1. So we're just going to add 180 degrees to it to get to the third quadrant. So our answer is actually going to be 236.3. Well, I'm totally off there. 236.3.